Now we're in homework 6, problem 2. And in this problem we have the joint density function of x and y. Okay, so we have the joint density function of x and y equals to the large B, and we have the interval that the square of x plus the square of y is no more than 1 and 0 otherwise. So we have these conditions, and from this guy we know that the picture should be like a circle, and x and y should be inside the circle. So in the first question we need to find B so that the density function should be a valid joint density function. So it's an easy question, and because of these guys we can set x equals to r multiples cosine theta and y equals to r multiples sine theta. So just transmit this form, transmit the formula, and we got this. And finally we got b equals to 1 divided by pi. So that's the first question. It's an easy question. So okay, now in the second question we need to find the expected value of x, and x in the condition of y, and x in the condition of big Y, and other thing. We just need to calculate the expected values of these guys. So first we calculate the expected value of x. So just use the x multiples the density function of x. We got this from the first guy, because y is no more than this and no less than this. So we can use this to calculate the density function of x. Also because we got this. So because this guy this equation this function is an old function, and we know that from -1 to +1, the value of this in this integral transmission should be 0. So this is the expected value of x, and the expected value of x in the condition of y, the small y, and we have this, and we put this into and the density function of x in the condition of y should be like this. And finally, because this is an even function, and when it multiples x, it should be the odd function, so the value should be 0. And also this guy should be 0. From this we know that. So now we need to calculate the expected value of y, because x and y are symmetry. Due to symmetry, so the expected value of y and y in the condition of small x, and this should be all of them should be 0. So now we need to calculate the value of the expected value of x multiples y, and we just put this xy plus the multiples the density function of x and y, and we got this form, and finally the value is 0. So all of the expected values are 0. So now in the third question we need to prove or disprove that x and y are uncorrelated. It's easy, because according to the definition, when they are uncorrelated, the expected value of x multiples y should be equal to the value of expected value of x multiple the expected value of y. So from the second question we know that all of the expected values are 0. So it's easy to get this guy equals to this. So x and y are uncorrelated. That's the whole story of the second problem.